I did this demo where you drop a basketball and a tennis ball on top of it and boom, it shoots up and it goes really far. And someone said, hey, but how do you know how to find the ratio of masses for those two things? Here's how you do it. So imagine that I have the basketball bounce up and then the tennis ball is going down and they have the same velocity but in opposite directions. And what I want to do is to have them collide such that the bottom mass stops. Now, if it's an elastic collision, two things are true. Conservation of momentum, conservation of kinetic energy. Elastic only for the conservation of kinetic energy. So here's my momentum equation in one dimension. So I have mass 1 times the initial velocity minus mass 2 times that same velocity. They're going equal and opposite velocities. And then they have some final velocity v2 and the other one stopped. So only mass 2 has momentum at the end. Now the kinetic energy equation looks like this. It's in pink, so you can see the difference. 1/2 mv squared, 1/2 m2 v1 squared, 1/2 is the final velocity kinetic energy. Now right here I can divide by 1/2 m2, and then over here I have v1 squared I can factor out, so I get this. So at m1 over m2 plus 1, v1 squared is v2 squared. Now let's go back to the momentum equation. So the momentum equation up here, I can factor out v1, and then I can divide both sides by m2, and I get this. m1 over m2 minus m2 over m2 is 1, v1 equals v2. Now I have v2 and v2 squared. I just have to square both sides of this equation, and I get this, v1 squared, v2 squared. Now I can set these two equations equal to each other. That's equal to that, and then I can solve for, I don't really care about v1 squared, it goes away, and I get m1 squared over m2 squared minus 3m1 over m2 is 0, or m1 over m2 is 3. 3 times the mass if it's a perfectly elastic collision. And that does assume, here, let me get my ball. So this assumes that it goes down like this. This one collides with the ground first, bounces back up with the same velocity, has a perfectly elastic collision with the ground, and then we have this. It's still a good physics problem. I like it.